very familiar with these things. So I think it's maybe our 12 or 15 or something like. We need to count how many conferences we organize here, because we have been running these conferences for, I don't know, 4 or 5 years, 5 years now. So every term. So we have a very good group here on STEAM education. So we have more than 40 PhD students and many colleagues here. And then we also develop GeoGebra here. Just a reminder for the new people who are joining the room, if you can just write your university and country to your full name, then that would be nice. And then maybe in the beginning, just for some minutes to turn on your camera for the speakers and our group to see you, then that would be very nice. And welcome everyone. So then the group is coming, and then we are here with Imam and Susanna in the mission control room at JKU, and then all the other organizers and participants around all over the world. So, and very nice to see all of you. And we have 2 more minutes before we start our first speakers, who are already here, ready for for their presentation and good message. So if there anything then that we need to address in the beginning, just let us know. And then the conference will be running today and then tomorrow morning. So it will be interesting. Yesterday we had a very interesting session with more than 170 participants. So you can find all the things on the YouTube. And then of course we will collect all materials on the website. So Eva is collecting it, and then we will put it for you to reach. So I think we should start, right? Because we have 1 more minute. So welcome everyone, and thank you for joining us, and thank you for the organizing team for making this possible. And then we would like to welcome our 2 speakers, Benjamin Rott and Moritz Sümmermann from Germany. I hope I pronounced it well. And so I know Benjamin for quite a long time, and then hopefully Benjamin will join our team here in Linz, and then he already had many appearances in our group, and then he's doing really amazing research, same with Moritz. And then I think you will have a great presentation about different views on design. So thank you very much again for accepting our invitation, and we are very curious what you are going to say. So thank you very much for everyone, and enjoy the session and enjoy the day, and then we will come back after the presentation. So Benjamin and Moritz, the floor is yours, or the screen is yours, sorry.
Yeah, thank you. Moritz is going to share the slides.
Okay.
Yeah, it works. So yeah, hello everyone. Today we will speak about the value of design in mathematics education. And first, I want to tell you the story about my co-speaker Moritz Sümmermann and how he got his PhD. When Moritz joined the Institute of Mathematics Education at the University of Cologne, it was his idea to use his programming skills to obtain a PhD. In the course of this presentation, you will see some examples of the software he programmed during his time as a PhD student. So colleagues at our institute, including myself, were skeptical regarding this idea. shouldn't it be necessary to conduct an empirical study and or to develop theories regarding the teaching and learning of mathematics to get a PhD in mathematics education? And therefore, we started looking for examples from our community and other scientific communities, whether there was a precedent for his idea and whether we should even consider promoting him to a PhD with only programming. So as Moritz aimed for a cumulative dissertation, a related question was whether it would be able for him to publish his results, so his programs, in mathematics education journals. And regarding this question of publication in mathematics education, in his keynote at the 2018 PME conference in Umeå and in his 2019 For the Learning of Mathematics article, Mogens Nis reflected about the development of publications in mathematics education journals. He criticizes that empirical studies are becoming more and more prevalent, with position and opinion papers as well as theoretical discussions being very difficult to get published nowadays. In this presentation, we would like to continue this discussion of Mogens Nis, wondering whether the development of software for mathematics learning environments or even design in general can be published in our journals. Of course, there are studies or even research strands that seem to allow design to be published. However, we will take a short look at the most prominent research strands, showing that they do not fit what we have in mind. So first off, there is an admittedly small community focusing on educational design as opposed to educational research. The community is organized in a society. Here you see the picture, the International Society for Design and Development Education, and they publish an online journal, The Educational Designer. However, this approach, named Science of Design sometimes, focuses on the design process, reflecting upon the theory of design, not on the designed products. Therefore, even in this community or this online journal, the design itself, that is the artifact or software, is not considered to be research and cannot be published on its own. Another well-known strand of research is design research or design-based research. An example for design-based research is the dissertation of Birte Pöhler, who graduated at the Technical University of Dortmund. Some of you may know this specific research project because last week, Birte presented it in the Yermi webinar series. So what did she do? Birte developed a learning environment regarding the use of percentages. However, it was not the design of this learning environment that got her her PhD. Instead, she focused on individual learning pathways of students, as well as the refinement of our theoretical knowledge regarding percentages, and especially on theories regarding students with language difficulties. The latter, that is theory refinement, is characteristic for design-based research. Therefore, the design of a learning environment is not sufficient to get published in a mathematics education journal. There is another strand of research that might fit design. We are now talking about the German tradition that was highlighted at the 2016 ICME conference in Hamburg, Stoffdidaktik, or subject matter didactics. Following this strand of research, problems, learning environments, and contents for learning are analyzed from a mathematical point of view to identify potential difficulties for learners. It might be true that Stoffdidaktik encompasses some parts of design. However, this is still not what we are looking for. The design of an app or programming software would certainly not fall into this category. Furthermore, as Thomas Janke points out, and in accordance with the criticism by Mogens Nis that we started with, articles of this strand of research are slowly fading from the journal published research landscape. And the bit that is remaining almost always adds an empirical component to its publications, as Erich Wittmann or Gerd Stubring stated. Okay. So the closest case of someone getting a PhD for design and for a program is probably Markus Hohenwarter, who in his diploma thesis and in a continuation of this in his PhD thesis described the development of GeoGebra. However, a first version of GeoGebra already existed when he started his PhD thesis, and his thesis also encompasses empirical studies regarding the usability of the software. Therefore, he did not get a PhD just for his programming skills.
Okay, so to maybe understand this better, we can look into other disciplines which have incorporated design. So this is on the left, a friend of mine, Patrick. He was just doing his PhD in physics. And in front of him is a part of the work he's working on. He's working on the design of some chip, which is then used in some sensor. I'm no physicist, so I really don't understand the details. But he really just works on the design and on the construction of this sensor or this microchip. And in particular, his work does not involve the gathering of any empirical data or empirical analysis or something of the sort. And he's not really alone in this. There are really prominent examples. For example, this is Gerd Binnig and Heinrich Rohrer. They were two physicists who received the Nobel Prize for, and I quote, the design of the scanning tunneling microscope. So this Nobel Prize they received, again, was only for the design of this microscope, not for the applications which it was then used for with great success. And of course, there's another reason for this sort of thing in physics. You have these large projects. Here's the CERN, pretty well known, and there are a lot of people working on this. And they can't all be analyzing data and conducting like sort of empirical studies as, so some people have to build this thing. And physicists chose to do this as a part of physics and to not let, for example, engineers do this, but to do this as a core part of their work as physicists. And back to mathematics education, what kind of designs or design objects or artifacts are we talking about here? The things we first had in mind were something like the DGE, so dynamic geometry environments, such as GeoGebra or Cinderella. And in that sort of same category fall two of the things I worked on. The first is Ariadne, and the second is called Not Portal. And I will shortly present them now. So Ariadne is a software where you can have or build basic construction of topology. So you can draw dots, you can draw paths between these dots or points, and then you can drag them around like on a tablet or a smartphone or something and try to connect them. This is then called in topology homotropy of paths. And the goal is to connect these two paths that they lie completely on another. And as you see, the computer helps a bit with that because moving such a one-dimensional object, a path with a zero-dimensional object, the point of your fingertip, is a bit complicated. And now they get the same color, which indicates that they are homotopic. And that's, of course, not so interesting because, I mean, every two paths here are homotopic. You can always find a homotopy between them. But you could also, in the software, build these punctures of the plane and, for example, build this path that goes from it back to itself and then ask, is this homotopic to the constant path, which is always at this point? And you could, again, try dragging this around or use this contraction tool that I built in. You touch the path, and then it automatically contracts this path. And so this path is indeed homotopic to the constant path, as you see. But you could also, again, draw a puncture and then have a different path going around. And this path is probably not homotopic, but how do you see that? You could, again, use this contraction tool, and you see this doesn't work. It doesn't contract the path completely, but maybe this is the fault lies with this contraction tool. Maybe there's like a smarter way to do this in somehow. And so I built another tool in, it's the small spiral you see in the corner. And this is the winding number tool. you touch a path and a puncture or obstacle, as I also call it. And then this sort of traces the whole path with this laser thing and draws the spiral. And in this way sort of counts how many times you wind around the puncture with the path. And the next thing to see is then that this is in some way invariant under homotropy, which means that if I change the path a bit, if I drag it around a bit, this doesn't change the winding number. So the winding number, as you can see, is built, and for everything you get, you build more on the spiral. You have to go back in some way, so the winding number stays invariant under this under homotropies. And in this way, you have in some way maybe even proved that this path is indeed not null homotopic, so cannot be contracted to a point. And this actually, this construction mirrors the technical topological proof very, very closely. Another environment that I built, something maybe completely different, is not Portal. So it's just an environment where you can have a portal, as you see here, just as you maybe know from shows like Star Trek or other of these space shows. And this is something you can, which I actually built for virtual reality. So you can actually, in this environment, go through this portal, explore the world on the other side. And it's a really simple portal. I mean, there's mathematically not really something interesting about that. I mean, if you go through this loop and back to where you started, you're in this water world. And if you go back again, then you're in the snow world. So nothing interesting. But you can take this boundary and then put a knot in there. So now you have this knotted portal. And I mean, the same rules apply. If you go twice around a strand, you are back in the world where you started. But now the question is, of course, what happens now? Are there now different worlds? How many are there? And this is actually a mathematical theory behind this. And so this is how it looks then. And if you then go through the portal, let's see if the video starts. Yeah, great. You go in another world, you go around, and you can choose another portal to go through, maybe go back through the world where you came from and look at the portal. And you can do, I mean, this is recorded on a PC, but you can do all of this in virtual reality, which is quite fun. And of course, maybe different to seeing this drawn on paper. Going around the different worlds a bit. I mean, if you want to, you can guess how many different worlds there are here. I mean, we see the white, the yellow, blue, the forest, and the red one, but there are more. There is more. Okay, so these are examples, but why not take even more things into this design, research, however you want to call it, approach? For example, curriculum proposals. If you have a well thought out curriculum proposal, why shouldn't that be considered as research in itself? Or sets of interesting problems. There, an example could be the PISA studies, where you had the problems published together with the empirical research, but the problems could be discussed and refined independently of the empirical study, and thus could be considered as research in itself, or digital textbooks or textbooks of any other sort. So there's plenty of design happening in mathematics education, but it always happens as part of something else. And why should we include this design? So why shouldn't we, I mean, why not keep the status quo sort of, where you have a design as a part of some mostly empirical research or theory building? And there are several reasons in my opinion. So the first is that if you have design as a part of an empirical research study, it is a tool for this empirical research study. So this means that the design, so by design, sort of, the artifact you're building will be tightly constrained, bounded, and small in scope, because you want to use it as a tool to understand the interactions with this artifact. You don't want something complex and and like a really rich, complex learning environment. This is not your goal, and this is kind of opposite to what this other kind of design that we have in mind is about. Another thing, as we saw before in the case of physics, the CERN is a very large project with a lot of division of labor going on there, and this sort of thing should also be possible in mathematics education. So you should be able to have one researcher working on the construction of some software or writing textbooks, doing this sort of stuff, and another researcher can then take this and conduct empirical studies with it. But both of them should be doing research, and not one of them should be a mathematician or a programmer, and the other is then a mathematics educator. And tightly connected with this is the third point on gaining knowledge on design, that if you let other people do this, so non-researchers, for example, in the case of physics, if physicists would let engineers build all of these tools, they would give away a lot of the knowledge that comes with building these artifacts and these software, whatever you're constructing. And in case of mathematics education, it's even kind of worse, that there's a lot of development going on by large companies such as Google, which are investing a lot into this mathematics education software development sector. And this is kind of the community is kind of giving all of this knowledge on design out of their hand, and in this way are forced then to treat all of these artifacts as kind of black boxes. And I'm sure that this is not in the best interest of mathematics education. Of course, and this is really of course, not every design constitutes research. So you can't just take anything you build and believe that it will have to be published in some kind of journal, and the journal will have to accept it because design is now research. As with every other field of research, we will have to find some criteria which qualify what is research and what is not, and what is like kind of a good design. And such criteria, of course, cannot be forced onto the community, like this is design and everything else is not, but they will have to be established then in a process. A starting point can be found in this design-based research approach, where Plumb identified, or citing Niven, identified 4 criteria. He talks about relevance and consistency. Relevance is sort of content validity, is the content. Does the content make sense? And consistency is then, does the tool or artifact, the software, make sense? Then practicality, can you actually use this for what it has been developed? And effectiveness. And this is kind of where design-based research, this is where the empirical component in design-based research comes in and says, does it work as you intended after testing it? But of course, this could also mean, does it work? And this can also have a theoretical underpinning. So you can also find some reasons why this software or tool you develop could be effective without having to conduct an empirical study.
So to pick up from where we started, what is the moral of our story? Did Moritz convince the members of our institute? Did he get his PhD in mathematics education for his programming work? Actually, he did not get his PhD for creating digital learning environments like Ariadne or Not Portal. Moritz got his PhD for his reflections about teaching and learning of mathematics with regard to design and technology. He reflected upon the mathematical background of his programs, the impact of technology on the process of arguing and proving, as well as on the theory of embodiment. And last but not least, he reflected upon the value of design in mathematics education, similar to what we presented in this talk. You find it here in this FLM paper. So, did Moritz convince you? It is now up to you and our discussion. Should it be possible to get a PhD in mathematics education, mainly for designing a learning environment or a test, and especially for programming a digital environment? Should design be a part of our community and our traditions? Or is designing and programming something we want to do in addition to empirical research, or even something that we want to outsource to designers and programmers who might not have sufficient background regarding the subject of learners and their needs? Yeah, we are looking forward to discuss this with you in the remaining 15 or 20 minutes.
Thank you.
So thank you very much for the very interesting thoughts, and I completely agree. So essentially, we are doing very similar things here, and then I think it's very important to include design, and then also the kind of feedback loop for the design of these environments. But I think we should ask the audience first, because before we start discussing as well. So, Clemens, maybe you can say something, and then afterwards, Irina. That's why are you convinced, Clemens? I know why, but I think it would be nice if you could share.
Hi everyone. Thanks, Jolt, for giving me the time to reflect on it. Thanks, Benjamin and Moritz, for an interesting talk. I'm also doing educational design research, and I'm in the same struggle that I always miss the appreciation of the design behind everything. So in every conference, everyone is just asking, so, and what interviews are you doing, and how did you get the data? And I'm having the greatest ideas out there put in my design, but nobody cares for it. So everybody just asks, and how are you evaluating it? Is it everything? So I think the two main points of educational design research, which is closely linked to design-based research, is that you need both. So you need your design, you need your actual product, a working product in the end, and you need the theoretical underpinning of why it works. So with these design principles, so the principles behind your design that help you understand how everything is connected, and that also always, these two things are always closely linked. But I think just as it was in your case with where you said that you are actually writing a program and just evaluating if it works and if it gives the results that you were looking for, this should already be enough of a proof that it actually works. So it's yeah, that's just my idea. So I still think that there needs to be a proof that it works, because I just wanted to type this thing that in theory there is no difference between theory and practice, but in practice there is. So if you don't throw it, if you don't really make it work and prove that it works, and if it does what it should do, then I think this is sufficient proof. And yeah, then it's
so maybe think of a large project with someone just programming and another one testing. Should only the one testing get his PhD in math education, or also the one programming? In this whole project, I totally agree that it also should be tested. But should the same person that programs be the one to test it, to show that he or she is able to do math education?
I think there should be a way to link these two things. I also have the problem that in larger projects, it really gets a lot of work if you have to do both at the same time. So why not let one do collect the data and focus on one part, and then just give the data that proves something to the one who did the design. But I think also in evaluating the data, I got so much insight into what is actually out there. So I think it's still valuable to link up the two things. So I think it's just a matter of how you link the two parts of it.
Yeah, or if I may add, and I think you might agree, even for a single PhD project, wouldn't it be nice to be able to just publish your program, and in a second publication for your cumulative dissertation, you publish an evaluation? But at the moment, this is not possible. it's not possible to just publish your program in a math education journal and then try to publish a second. You always have to publish empirical data, and the whole programming work just becomes a short notice in the methodology section.
I think
so,
what I saw in sorry, just one more word, sorry. What is in educational research, it sometimes it works that I saw it that others did it, so that they're splitting their work apart. So in the first publication that they're doing is just a theoretical thing. So they're just publishing the preliminary design principles. So which is the design, what you're actually doing, without any evaluation of it, so without research. So in educational research, it is possible. I'm not in math research, but I think this is just the point that you are discussing, and I think this is valuable as well, that you're just coming up with the design itself, and then in a second paper you're publishing the results.
Yeah, so we will have some questions. So Irina, then Brian, then Reinhard will be then the next questions or comments. So from and I would like to add a little bit, because I think it's really important that also that how the PhD is designed, that it's a single person project, but I think we are moving to a multiple or a team project. PhD as well. So I really encourage the collaboration of my PhD students. And then this is what Moritz mentioned with the CERN example. So if you look at the publications, it's one publication for 30 pages and then 300 pages of the 7,000 authors of the paper. So I think we need to make this progress, and then in the same time we need to progress on the methodology. So we are, if there is time, I will explain that we are trying to make some updates on design-based research, and then we are doing a very interesting experiment with Martin on user experience research connecting with education research, which also needs to include a multiple players. So maybe Benjamin, we can work on this. So I think Irina, and then Brian, and then Reinhard have their say. And then please post your questions in the chat, and then we will call you for the questions. So Irina, you would like to say something.
Yes, I would like to say that if we're talking about education research, then the design needs to be directly connected to education, and that cannot happen just by providing a program or by designing an artifact, whatever artifact is. There needs to be some form of evaluation. I'm not talking about empirical data and analyzing empirical data of how that particular program is implemented, but I'm talking about evaluation of the program itself through some form of testing and connecting it to education, so that we can say, yes, it is an education product and not a computer science product, for example. So that, I think it's what we're talking here about, and the issues that you're raising. There's like actually a couple of issues that you raised. One is, what is education research, like, and what role design plays in education research, and whether design itself is education research. And I believe it is, if it is directly connected. And I want to mention, like Clemens said about underpinning, theoretical underpinning. So it's on one end, but on the other end is an evaluation of whether that product really is meeting those theoretical underpinning and really applicable to education research. So that even in physics, you mentioned, I actually have a physics background, educational background. So even in physics, when people design something, it's not just like, let's put things together. They test it so many times before it becomes a final product that somebody else could use. And we need to do the same in education of any product, and that should be a PhD. But the second issue you raised about individual versus collaborative work, and who does what and who gets credit for what, and that's maybe more complex the way PhDs are designed, because PhD is still part of education, and in education we really value both collaborative but individual. We want to see individuals and what they can contribute, and separating in a large project work of individuals from work of a team might be very complex and very difficult. And that's why PhDs are designed this way, because you don't give a degree to a group, you give a degree to each individual. So that's more complex, and we can probably talk about it. I agree though also that it's great when PhD students collaborate, but very often in a larger project, each PhD student has their own unique role that could be evaluated individually, and on the basis of that, PhD is granted. So it's not like just a technical piece where, okay, you're doing this, you don't know what is it for, and you're just doing that, and then somebody else is gonna really evaluate it. So that's my thoughts.
Yeah, maybe a short comment on that. And this also relates to what Clement said earlier, is the question on what you both said on how to sort of connect this then with education. And both of you said that it is important to have like this sort of educational background for and reasons why this is not a computer science project, but really an education project, in this case, mathematics education. And what you said also about physics, that the products are tested there. The question is sort of how should this education project then be tested? Should this be tested with like educational theories, or for example, in this case of mathematics education, with mathematics theories? In the physics case, they take like engineering as their sort of mother discipline, and say, okay, we test this chip by applying some current at this place and check if this is the resulting current that comes out, which is sort of engineering practice. And for example, the projects that I did, I think you could ask questions relating to the mathematics. So does this represent the mathematics in a faithful way? Does this explain the mathematics that is going on there in a way? So it is a bit the question if you see it more in the like subject direction or in the education direction, I think. But yeah, I think very valid comments.
Yeah, I'd like to add another comment. You said this is related to the question, what is education, or what is research on education and research in math education? And I agree that this taps into this question, but I think design has always been a part of math education research, but a part that is hardly publishable. And this goes back to the discussion that Mogens Nis initiated, that what we are able to publish in our big name journals is maybe not what we do and what we have done for the last 5 decades. So maybe this is more a question of how the publications and the journals evolve, and we should think about this. And if we want to allow design to get published, of course, as Moritz said, we would need good criteria, and one of those criteria might be some testing with educational theories or so. And these criteria would evolve if someone tried to publish a design in big journals like ZDM or ESM or so on.
Good. So yeah, I think it's a very important topic to address. And then next is Brian, then Reinhard. But please introduce yourself when you are asking a question, just to get to know each other more formally. So Brian, your question is next.
Hello, I'm Brian Sheldon. I hailing from California via JKU, and originally a number of things have been said that are very similar to what I was thinking, and I don't need to repeat all those things. I was going to point you back to your own reference to Plom's work and needing relevance and consistency, practicality and effectiveness, and those being very closely tied to empirical research is like certainly something you're aware of. And so then it made me think, okay, what we're really discussing here is individual versus teamwork, and the idea of a team-based project with multiple PhD students. I don't know how common that is because I'm new to this arena. And interestingly enough, I am here because I have 20 years of classroom experience developing all kinds of ideas and applying them to students, but nobody cares because they're just my own things in my own classroom and nobody sees them, and I don't know how to bring that out to the rest of the world. And so I'm here to learn how to do that, in a sense, to do research on my own designs by themselves. Only my students are aware of the work that I do, and it's their opinion whether it's any good or not. And that's neither here nor there to the rest of the world. So there's a sense in which I would partner with someone who already has a PhD to teach me how to do that and to take my design and then make it presentable to the world. So then the question is, what if the people I'm working with as I do that also are working toward their PhD? Then as a team, as we learn to do that together, do we all collectively win the prize, as it were? So those are just my thoughts. I don't know if there's a question there as much as I was trying to clarify where you were coming from. And at first, I thought one thing, and then based on the comments, it seems more about this group idea on bringing an idea forward, because it seems like you're fully aware that certainly some type of testing is necessary for any idea.
Yes, but just to clarify, I do believe that some kind of testing is necessary. I really do not believe that any testing needs to be, or every testing needs to be, empirical. So I read enough studies where you read like the empirical justification, and of course this worked. Like this was clear from the beginning because of the great theoretical reasoning they had that this would work. Especially if you're talking about like mathematics education. If you have like a really well-designed math education project, you can say before that some things will work and other things maybe are not so clear. That's not saying that you can't gain a lot of insights by empirical research, but not every testing has to be empirical. So, but that's like maybe two different issues here.
I've seen some very well-researched bad pedagogy.
Yeah, that's true. Yeah, that's true.
Yeah, and of course we can step back from the high aim of getting a PhD for just programming, but shouldn't it be possible to publish design without getting a whole PhD for it, or even for a researcher who did his or her PhD several years ago? Shouldn't he or she be able to publish a well-designed test without having to conduct a large empirical study to show it? Just publish, oh, we did this, we constructed the problems and tasks for this and that reasons, and those were the thoughts that went into it. Should it always be necessary to have an additional empirical study or not? This is a related question.
Okay, thank you. So Brian, don't worry, I'm here. Then make sure that you will get the prize. Reinhard, you are next.
Okay, good morning, everybody. My name is Reinhard Oldenburg from Augsburg University, and I do some design as well, as you may see in my talk later this morning. And of course, I highly appreciated this talk and would like to support its intention. And perhaps it is not so a good idea that which came up in the chat to bring such things to mathematics education, to computer science education, because computer science education journals turn into this empirical way of living as well. But I think another argument may be useful in discussing with colleagues, and this is the argument that, for example, the design of a test instrument can be published. For example, if you design the test to measure some, for example, modeling competence, or measure basic mental model of integrals, you can publish this in journals like the ZEM, and this is also design of something which is not useful in itself, but only useful if you put it in the bigger scale approach of a didactical project, because measuring alone is not didactical research in itself. And so it's part, just in the same way, designing a test is part of a bigger research project, just like designing a program.
Thank you. So any reflection from Moritz and Benjamin?
Yeah, I would say that of course that there are many things that are sort of done in mathematics education, which are right now then not considered research and considered research for me means sort of not valued as much, because what research is sort of what we define as a community, what research is. We define that quantitative studies are research or qualitative studies are research. And yeah, that's a good example for these test instruments.
Yeah, I think there might be cases where test instruments without empirical studies got published, even in high-ranking journals like the DM. But I tried this once, and the reviewer's comments were, you have to test this. There has to be an empirical study to show that your test really discriminates good from bad, and so on. So, and as Moritz said, we as a community define this. We are all, or will be reviewers for journals, editors for journals, and it is up to us to say this could be acceptable or not. And when we as reviewers say you need to do an empirical study, then we add to this problem, if you might say so.
And maybe to comment on something that was said in the chat on just establishing new journals. So many journals do not explicitly sort of forbid this kind of non-empirical research. They say we publish anything that is of interest to mathematics education, but then in practice, it's not everything that is of interest to mathematics education, but things that are of interest to mathematics education and have an empirical component attached to them.
Thank you. Yeah, and then also what I mentioned, the methodology, that many times the design involves evaluation, because it's the same thing. So this kind of user experience approach, we can use this, and then there are some initiatives then that I will say later. So thank you very much, Reinhard. And then Musa, you would like to say something.
Oh, well, thank you. I am Musa Simon from Tanzania, the College of Business Education. The topic is very interesting. I have to admit that I'm not coming from mathematics, I'm coming from language literacy. But when the topic was being presented, I was thinking from the perspective of what we call 21st centuries and the multimodality of the current literacy skills. So as we are asking questions on what can we do for collaborative project, the question comes that if we don't acknowledge the collaboration of these students, how can they internalize the point of collaborative as one of the important skills in 21st century skills? So that means we are going to be preaching what we don't practice. Again, if we think of like the design is not the role of the educator, perhaps this is the role of the engineer. How are we going to make people believe the point of STEM education, where we find engineering is one of the part and the parcel of the component of every learner? So I'm supporting the current topic by arguing that we need a comprehensive framework through which all these things could be addressed in the way that once the students collaborate, each individual should be recognized, and his contribution or her contribution shouldn't be ignored. And again, is that even when it comes to the design, once it's not tested, but the artifact is there, if there is a way that we can evaluate this artifact before testing, it could also be better. We have to acknowledge that. Why I'm arguing for this is because we have so many artifacts that have come in place. As educators, we are trying to go and test them pedagogically in a classroom. Some of them are not working, although probably the engineers thought they could work in our context. So if you are saying because this educator has not yet tested, that's why we don't recognize, there are so many questions that are coming upon. So that's all. Thank you.
Good. Thank you.
Just a short comment. Thank you. I have seen a lot of research with published research in good journals with tests that I think are very boring or not well designed, but there is a sound empirical study and they calculated their p-values and then they got published. And it would have been nicer to put more thoughts into design of the test and less time into the empirical study. So yeah, I totally agree that this is important.
And also a short comment on this, because this always comes up as sort of two issues. On the one hand, this collaboration issue, on the other hand, this design issue. I think they're really closely related, because if you have one and not the other, you come into weird situations where you have like, okay, design is research, but you can collaborate. That would be really weird. Or you can collaborate, but if you have design, it's not published. Then like one person in the group or several persons are valued less than the other, because half of the group can get their research published and the other one cannot. So I think they're really like closely interweaved, these two issues.
Yeah, or even a practical issue regarding this. If I have two PhD students, one is doing the programming, maybe in computer education work, and the other is doing math education, I am as a math educator only able to grant a PhD in math education. What should I do with the other one? Give it to another colleague to say, oh, it's yours to give a PhD because I'm not qualified to judge this, even though he works closely with my other PhD students?
Yeah, I think it's very important issue. So maybe, Benjamin, we have a topic to think about it. And then I completely agree that many times we are fighting against this boring research. So it looks that every boring research needs to have a t-test because without a t-test, it's not possible to publish. And then those could be really disaster. I think that whole the tests are done. And then it has like 1% effect size, but the t-test is satisfied. Anyway, so we have only 1.5 more minutes. So Oliver and Sam, maybe you can give a very brief comments, and then we need to close the session because we'll have a break, and then we will have very interesting presentations in the breakout room. So Oliver, just very briefly, if you want to say something.
My idea was basically to publish programs in MINT disciplines or STEAM disciplines like the computer science education, if that is possible, as a thought. And I was not aware, Benjamin, that you are thinking you are giving knowledge away to other disciplines, because I think STEAM is, we are all brothers and sisters. I'm not sure if this is a common sense.
Yes, of course, I agree that we should work together, but we wanted to stress this example of physics, and they don't give away their knowledge to the engineers. It stays in physics when they build. Of course, they collaborate, but maybe giving away knowledge is the wrong term, but say that construction of these artifacts is also part of physics. And in our case, design of instrument is not only part of other STEAM-related communities, but can also be part of math education. Maybe this is framed in a better way. You are right. Thank you.
Thank you. And then also subjects are merging, and then it's not really possible to do just a lone wolf research anymore. So like the CERN example. So Sam, maybe you can have a very short comment or question, and then I think we need to have a break because you have some. So Sam, do you want to say something? Do you hear? If not, then probably we can close the session. So Benjamin and Moritz, very valuable contributions, and I think it's a very important topic. And I think then there is a group there is a growing need for doing this kind of changes. So, for example, the implementation group in CERMI is looking at design and then also some kind of evaluation. So then that could be, and a way to go. And there is a new journal on implementation studies, which is design and then a little bit of testing. So I think then that could be an interesting way, but maybe then this could be a very good topic when you come here, or maybe we think about it, maybe Reinhard, and then we could have this discussion. And then Moritz, you are also very welcome to join our group or the discussions as well. So thank you very much. It was a great contribution. So
thanks for the invitation.
Thank you. So
Yeah,
you are welcome to stay around. So now we have now 8 minutes of break, because we need some break. And then please try to get back maybe 1 minute before 9:40, and then we will create the breakout room, so you can find all the talks, and then maybe you can decide in advance that which parallel group you would like to be. And so see you back in some minutes. Have a good coffee, and then so on. So next time we will serve your coffee here, and then so on. And then maybe Eva will say something before the